Hello everyone. Today we'll be presenting our project on time series forecasting of internet job vacancies using Rmit modeling from Team Series Square. Myself Pratibha Manjunatha. Here we have used the dataset which is monthly internet vacancy index from 2006 to 2025, which is sourced from Australian government jobs and skills portal. So here is the original plot of the data which is taken from 2006 to 2025. Let's visualize the data now. So first of all, let's consider the 5 important points. The first one is the trend. So here, there's a clear long-term increase in the vacancies, especially post-2022, which is like hike here. This indicates non-stationarity, which we address through differencing in the further steps. Coming to the seasonality, the ACF plot didn't show the repeating yearly pattern, so seasonality wasn't a concern here. Now let's check for the behavior. ACF and PACF of the different series reveal significant spikes, indicating which has both autoregressive and moving average behavior. Let's check the next point, which is changing variance. So when we come to changing variance, some mild variance change were observed. So we applied a log transformation to stabilize it. Let's consider the next point, which is changing point. So despite dips during the 2009 and 2020 crisis, the series remained structurally consistent as we don't have any changing point. After commenting on the first 5 important points, let's check for the stationarity. The original series was non-stationary, which is confirmed by the following test. So here is the output for ACF and PACF plots. So you can just check the ACF plot, which has slowly decaying pattern, and PACF has very high first lag, which indicates the series was non-stationary. Here you can check the outputs for the following tests. So first one is the ADF test, which is where the p-value is 0.37, which is greater than 0.05. Even when we check for PP test, the p-value is 0.83, which is also greater than 0.05. We can just confirm the things with the KPSS, where the p-value is less than 0.05. So by this we can confirm that the series is not stationary. Then the stationarity was achieved using second order differencing on the log transform series, and you can see the output here. After log differencing, ACF and PACF were plotted. So using the example, we can determine the P and Q values. So from PACF, we can check there are clearly 3 lags out of the range. So we can give P equal to 3, and there can be 2 more added, like 4 or 6 by considering the near miss. So similarly, Q, there are 4 lags which can be considered. So Q can be 4, or 2 are near miss, which can be 6. So from this we can conclude that P can be 3, 4, 6, and Q can be 4 and 6. Further, we used EACF and ARMA subsets to define the ARIMA models. So using EACF, the topmost O is in the position where I have marked the yellow box, where coordinates are 1 and 4. So the corresponding O's are at the position 1 and 5, and 2 and 4, and 2 and 6. By this we can define 4 subsets. So next, coming to the ARMA subsets. So here we'll first consider the top 3 things. So where we can get the p-value as 1, 2, 3 and q value as 1, 3 and 6. Depending on that, we'll create the ARIMA models. After considering all the models, we chose ARIMA 326 as the best model, as it has lowest AIC value, which is 3611.44, and the lowest BIC value, which is 3645 among all models. So it has balanced complexity, and performance is better than the simpler or more complex models. It captures both short-term fluctuations and long-term dependencies. It has all the significant values like AR1, AR2, AR3 are significant, so that you can check in this output. And we can also check it has the least ME, RMSE, ME, MPE, MEPE and MASC, so which I have highlighted in the bottom. Let's check the residual analysis. The ACF plot of the residual showed no significant spike, suggesting no remaining autocorrelation, which is a sign that the model captured the structure of the data very well. The residuals had roughly constant variance with no visible patterns over time. Let's comment on the normality test now. So which indicate that the residuals were approximately normally distributed, although some mild deviations were observed, which is acceptable in the real world data. Here you can check the p-value plot where all the points are above the line, which can be acceptable. Using ARIMA 326, we forecasted job vacancies for next 10 months. The predicted range is 2,21,843 to 2,59,861 vacancies. The trend continues to rise, indicating growing demand in the job market. Our model provides reliable insight that can support policy decisions and workflows